Okay, so the last problem that we left off with on day 3, and you're going to want your calculator and your formula sheet out today too, because we are going to look at some of those formulas. Okay, so beginning at number 10, you need to find the slope of the line tangent to the function at the point -1, 5. Okay, so what do we do when we see tangent line? What do we take? Well, you know this. Yep, power down in front, perfect. Derivative. So this is a derivative question. So to do the derivative, you're going to go f prime x equal to, as he said, power down in front. So your 2 gets multiplied by the -2 in the front, so I would have -4x. And then the derivative of -3x would be -3, and then the derivative of a constant would be 0. That's half of it. Now we need to find the slope. So you are going to find the slope by plugging in the respective x value that was given. So I'm going to say sub in x equals -1. So we're going to do f prime -1 is equal to -4 multiplied by -1 minus 3. Okay, so this is equal to 4 minus 3, which means our slope is just going to be 1. So m is equal to 1. And then next it tells you in part B to write the equation of the tangent line in slope-intercept form. So this is where you can pull your formula sheet. And on your formula sheet, you will have point slope form. And then you're going to multiply that through to get your final answer in slope-intercept form. So from your formula sheet, we're going to go y minus y1 is equal to m multiplied by x minus x1. So you're going to substitute in, and we get y minus 5 is equal to 1, and then x plus 1, because double negative. So I have y minus 5 is equal to x plus 1. Add your 5 over, and we have x plus 6. And again, what I've noticed you all do more often than not is forget equal signs for equations and just little things like that. So make sure you're being thorough. We've got y equals, and then x plus 6. All right, so that concludes all the problems we're responsible for on the day 3 sheet. How do we feel on those? Pretty good? Okay, moving into day 4. And again, as we progress, these are in order. So these are the topics that we did a little bit more recent. So day 4 material, I'm going to begin right at the top. I don't believe there's anything I'm going to omit on the front. So first question, find the point of inflection. You have a delta math question very similar to this too. What do I have to find for point of inflection? Yeah, which derivative though? Second derivative. Good. So this is just a continuation of the last problem we finished with. So first I'm going to do my first derivative. So power down in front, subtract 1 off the exponent. Power down in front, subtract 1 off the exponent. And derivative of a constant is 0. Now you're going to do it once more. So f double prime x is equal to power down in front, 6x. Derivative of -6x is the 6. Now you're going to continue and set this equal to 0, factor and solve. 0 is equal to, I'm going to GCF a 6 out of this, leaving me with x minus 1. So you're going to t-chart, and the only value here we have is that x equals 1. And then you need to find the respective y value as well. This is what students confuse all the time. where do you plug the 1 back into? The original, first derivative, or the second? The original. Again, I see this a lot and I totally understand why. It gets very confusing to figure out where it goes next. So in big letters, please, you are going to sub into original. It's really the only mistake I tend to see on these type of questions. Sub into original to find the y. Big note of that. So I'm going to go f of 1 equal to 1 cubed minus 3 times 1 squared and minus 1. I don't have that yet. Negative 3, thank you. So y is equal to negative 3. Perfect. So your point of inflection where this would change concavity would occur at 1, negative 3. Does everyone in their notes have written down to sub into the original? Okay, perfect. So number 2, write a polynomial function of least degree whose roots are 3 and then 2 plus or minus square root of 3. Again, those irrational roots are always going to come in a pair like that. So number 2, this is going to involve some multiplication. So you will be able to fit this on this paper if you write relatively small, or it might be something you want to kind of go over to your notebook for. So polynomial function p of x is equal to. I'm going to take these and flip the signs. So if the root is 3, the factor is x minus 3. And now next I'm going to go x minus, and I would encourage you to do this right on the original. So I'm going to go 2 plus the square root of 3. Close, close. And then I'm going to go x minus, and then 2 minus the square root of 3. Close, close. Now I'm going to work with my 2 irrationals. So I'm going to distribute that through, and then you're going to do a bunch of foiling. So this would give me x minus 2 minus the square root of 3. And then this would give me x minus 2 plus the square root of 3. And if you remember doing these from a couple weeks back, what's supposed to happen with these when you multiply them is you're going to see a lot of terms cancel. So go nice and slow. For spacing purposes, this is going to be 9 terms. Okay? So we have x times x is x squared. X times negative 2 is negative 2x. And then plus x radical 3. Minus 2x plus 4 minus 2 radical 3. Got to squeeze 3 more of these in. So I'm going to go minus x radical 3 plus 2 radical 3 minus 3. Let me know if you can't see anything up there. I'm going to do this. We still do have that x minus 3 here. Equal to the p of x. Okay. So you're absolutely going to have some terms cancel here. Just got to look through this really carefully. I'm going to use yellow so you can still see what's underneath these. All right, what cancels up here? Do you guys see it? X radical 3, excellent. Nice and light. You should have something else as well. 2 radical 3s, excellent. Again, go real light on the cancellation. If you want to use highlighters for your midterm, you're more than welcome to. Now what remains here is x squared. And I have minus 4x. And combine your constants together. I have 4 minus 3, which is just 1. Okay, now you know it once more. This one's going to be smaller. This is a 2 by 3. This is just 6 terms. So I'm going to go p of x is equal to. I have x cubed minus 4x squared plus x minus 3x squared plus 12x minus 3. And you do need to state your final answer in standard form. So you're going to do a quick rearrangement and then you're set. So polynomial degree 3 equal to x cubed minus 7x squared plus 13x minus 3. Okay. What's number 2? Again, during the year, you were good with those, nice and confident. What I saw most is, again, forgetting equal signs on that equation at the bottom there, and some little sign errors here and there as far as like your multiplication goes. Okay, those do take a little bit of time though. Number 3, this one's much quicker. Find the remainder of 2x squared minus x plus 3 divided by x minus 3 and state whether the binomial is a factor. What method of division is best here? Synthetic. But you're going to take the factor, flip the sign. Only when it's a factor do you do that. If it's a 0, you keep it the same. I go 2, negative 1, 3. Straight down is 2. Multiplying 6, adding 5. Multiplying gives me 15, remainder of 18. So this question just simply asks you to state the remainder. And is it a factor? No, because that produces a remainder. So that's all you have to say. So not a factor, has a remainder. Just abbreviate. Okay. Number 4, fairly easy as well and quick. Find all possible rational roots. This is when we did the P and the Q. So P was here, Q was here. And we did the list of possibilities. And that's all you have to do with this one. So we did factors of P over factors of Q. So factors of 15 are 1, 3, 5, 15. And then factors of Q would just be 1 and 2. Now I'm going to make my list of possible rational roots. The plus and minus can certainly just be placed in the front so you don't have to keep rewriting it. So I go 1 over everything, which is just 1, 3, 5, 15. And then now I'm going to put them all over 2. So that would give me a half, followed by 3 halves, 5 halves, and 15 halves. That's it. Those are your possible rational roots. How do we feel in column 1? Again, review is entirely for you, so please stop if you have questions or need clarification on anything. Back up to the top. Partial fraction decomposition. All right, so decompose into partial fractions. Again, you will always be prompted to do this with the language in the question. So what I need to begin with is factoring my denominator. So I'm going to factor this into multiplies to negative 10, adds to negative 3, would be negative 5 and positive 2. Next step is I write this as the sum of 2 fractions. So I go A over x minus 5 plus B over x plus 2. My least common denominator is 1 of each factor. So what you're going to do is multiply by which one it's missing. So my first fraction is missing the x plus 2. I'm going to just do it up here so you can kind of see it. And then my B is missing the x minus 5. Okay. So that's what I'm going to work with down below. So I'm going to go A multiply by the x plus 2 plus B multiplied by the x minus 5 And I'm going to set it equal to my numerator, which is 6x minus 2. Remember that there's really no need to actually factor that numerator because you're just going to work with it anyways. The next thing you do is you substitute values for x that produce zeros, but you have to do them one at a time. So what value of x would produce a 0 right here? -2, good. I'm going to sub in -2. This first part is entirely up to you. If you already know it's going to go away, then you don't need to show it as part of your work. This would be b, and then -2 minus 5. And then this is equal to 6 times -2 minus 2. Again, that first expression just cancels. It's not a requirement that you show that. And I'm left with -7b equals -14. So this is going to give me b is equal to 2. And that's going to get placed in your answer in a minute. I'm going to just box it so we can find it. And then next, I'm going to find another value that produces 0. So up here, I'm going to now use a 5. Yep. I'm going to come down here. I'm going to plug in +5. And I'm going to do A. And I'm going to go 5 plus 2 plus B, 5 minus 5, which is nothing. So again, you may feel free to omit that. And this is equal to 6 times 5 minus 2. Okay, so on the left, I have 7 times A. And on the right, I have 30 minus 2, 28. So A is equal to 4. All right, you're almost done. You just have to rewrite this now as the sum of 2 fractions. So now what I do is I go up to my teal one here and I just replace A and B. So your solution as a sum of 2 fractions is 4 divided by x minus 5, thank you. And then plus 2 divided by x plus 2. Again, that's another question that does involve a lot of work. That is called a partial fraction decomposition, if you need more of those. And those were in chapter, pretty sure it was chapter 4, if you're looking back. Next, your inequalities. 6 and 7 are kind of similar. First thing we want to do is get this to be less than 0. So I'm going to take the 1/6 and subtract it over. So on the left-hand side here, I'm going to have 2 over x plus 1, and then minus. So if you do -1 minus 1/6, that would be 7/6, and that is less than 0. You're going to find a least common denominator, which is going to be the 6 and the x plus 1. I'm going to try to do this using the least amount of writing as possible, just so it doesn't get all bogged down. So this fraction has the x plus 1. What would it need to get multiplied by? The 6. So 6 times 2 is 12. This one has the 6. It needs the x plus 1. So I'm going to do this. So that takes care of your numerator. And then again, you are looking for places for which it's undefined, which means I'm going to take the algebraic expression. And I also need to set that to be less than 0. Because again, I can't be working with something undefined. All right, so now you just solve both of these. That's the easy part. So on the left side, I would have 12 minus 7x minus 7 is less than 0. So -7x plus 5 is less than 0. So I would have -7x is less than -5. And what do we need to do with an inequality when we divide by a negative? Flip the sign, good. So I know that X is going to be values that are greater than and not equal to 5/7. Then again, I'm looking at my denominator. My denominator cannot be undefined. So I also know that X must be less than -1. So one way you can write this answer, I'm going to start with the smaller. So I can say X is less than -1, or because it would jump, X is greater than 5/7. Those of you that favored interval notation are still welcome to use that as well. So if you wanted interval on this, you could go from -infinity all the way up to, but not including -1, or from 5/7 all the way to infinity. So either or, however you'd prefer to write that. So my next. The only thing that makes this one different is really you've got that radical in here. So I'm going to begin and work with, and no common denominator needed, I guess. So X minus 5, I am going to immediately move the 7 over. Because for this particular question, because you have a radical, we need to isolate it. I'm going to take both sides and I'm going to square them. And I get X minus 5 must be less than 49. I add it over and I know X is less than 54. Again, you need to take into consideration places for which X is undefined. When you have a radical, you are going to pull what's beneath it, X minus 5. And for a radical, you must say that it is greater than or equal to 0. Because again, we cannot have anything imaginary with this question. So the other side of this is X is greater than or equal to 5. Okay. So these would occur in between. So you could write your answer like that, or you can go 5x 54, and you know you are greater than or equal to that, but less than 54. So that's fine. My interval people, you could do this. And then rounded bracket for the 54. Again, you don't need both. Pick what you like better. How do we feel in the front? Okay. All right, over the back. Let's see how far we get on these. Okay, if one root of this cubic equation is -3, find the remaining. If this is degree 3, how many more are we looking for? Very good, 2. Now, when I go to divide out the -3, do I flip the sign? I do not, because it's not a factor. I'm going to just do -3 and divide it out quick. 1, 6, 10, and 3. Write down, multiply, add, multiply, add, multiply, add. Again, you were already told that it works, so your work should reflect that. Now I take this resulting quadratic because you reduced it 1 degree and you solve. So I have x squared plus 3x plus 1, which does not factor. So what do you have to use instead? Quadratic formula. Yep. You're going to go x is equal to -3 plus and minus the square root of 3 squared minus 4 times 1 times 1 all over 2. It's fairly simple. So x equals -3 plus or minus 9 minus 4 is 5 all over 2. So that represents your 2 remaining irrational roots. Nothing more you have to do there. Number 9, you may omit. And hop down to 10. So determine the nature of the roots. When you are looking for nature of the roots, what are you substituting into? Just the discriminant. So it's the portion of the quadratic formula located beneath the square root. And then what you look at are the 4 possible cases. So we discussed that these roots could be real, they could be imaginary, they could be rational or irrational. So you sub in. So I'm going to do -3 squared minus 4 times 1 times -7. I get 9 plus 28, which is equal to, yep. And now you look at 37. The first thing you might want to rule out is 37 negative. No, so this is not imaginary. Is 37 equal to 0? No. So then next, can you take the square root of 37 evenly or not? Not. So this produces what we call real, unequal, irrational roots. All right, and those are the 4 cases that you have written into your notebook. Again, they can be real, they can be imaginary, they can be rational or irrational. Okay, so number 11, conversions. It says convert the degrees to radians. So if you look on your formula sheet, is that one provided to you? It is not. So you're going to do 220 multiplied by pi over 180. And it says in terms of pi, so you are not going to type the pi in the calculator. Does anyone have what this reduces to? 11 ninths, thank you. This is equivalent to 11 pi over 9. Done. Again, some of these are fairly quick. Back up to the next column. I want to take this angle, which is written in what we refer to as degree, minutes, seconds notation. And I want to convert it back into decimal degrees. This is strictly calculator work. Okay, so in your calculator, you are going to type all of that in exactly as it appears. Bear with me a minute. All right, so I am going to type in 123 degrees, which you are going to find on the second apps, followed by 17 minutes, second apps, and 18. And what key do I have to hit now? Yep, alpha plus, good. Again, it's kind of the oddball. Okay, so you can write down that first answer. So that first answer is 123 point thousandth is 3 decimal places, 289. All right, so that answer, again, strictly calculator work, is 123.289. And then 12b, you're going to convert that into radians to the nearest thousand. So you're going to go 123.289 multiplied by pi, and then divided by 180. And I would encourage you to do this. So parentheses. And then you're rounding those nearest, I got 2.15. So 2.15 radians. You may leave your answer like that, or you could do this. Up to you. Both are okay. All right, and then 13. Let's just start these. Let's see, because I don't want to rush. Find the exact values. Decimals are incorrect, so definitely make note of that. So 240 degrees. These have many parts to them. What quadrant does 240 fall into? I'm going to do this. 240 degrees. Step 2 is I need to find the reference angle. What is the rule in quadrant 3? Good. Here we go. 240 minus 180. And again, this is the point at which it should be an angle that you recognize. So do we recognize the sine of 60? So I'm going to go ASTC. So it's negative. I'm kind of making it big for emphasis. And then lastly, you replace it with sine of 60. Who remembers the sine of 60? Yep, negative radical 3 over 2. Perfect. Secant negative 135. If I were you, I'd add 360 to this. Then you can work with a positive angle. What is that plus 360? 225, thank you. And then you're going to plot it. So 225 degrees is once more quadrant 3. So I'm going to go 225 minus 180. And then this should be an angle that you recognize. So I'm going to do the secant of 45 before I forget ASTC. Secant is a reciprocal cosine, meaning in quadrant 3 it is negative. So you're going to pull the cosine of 45 and then flip it. The cosine of 45, unrationalized, is 1 over radical 2. So I'm going to take that and flip it. So if I flip it, I would get radical 2 over 1 and then negative in the front. If you use the rationalized version, you just have to do a teeny bit more work, but answer will come out the same. All right, let's finish up these last two. 660. How about this? Minus 360 to find something coterminal, and that's going to give me 300. 300 different quadrants this time. Where's that at? Done. Quadrant 4. So I go 360 minus 300, which becomes 60. I'm evaluating the cotangent of 60. Not forgetting to do ASTC. Negative again. I'm sorry, I seem to give you a lot of negatives. And then next, we're going to pull the tangent of 60 and flip it. So what is the tangent of 60? Tan of 60. Radical 3. And then you're going to flip it. So I get negative 1 over radical 3, which I then rationalize to produce a final answer of negative radical 3 over 3. Another negative. Last but not least, 13. What do you suppose you should do with that radian measure first? Convert it to degrees. Yep. So 4 times 180 divided by 3 is 240. All right. Quadrant 3 again. So I'm going to do 240 minus 180, which is tan of 60, which we just did. I do ASTC, and finally, you have a positive. I'm just putting that out front so that you know we checked for it. I'll circle it so it doesn't look confusing. Answer is square root of 3. All right. That finishes up days 1 through 4. Please remember that your Delta Math review assignment is due tomorrow morning. A lot of you have not started it. So that'll be your task tonight. It needs to be done. I think that deadline is either 7 a.m. or right before you, 9 a.m., right before you come in, okay? Those problems are not graded for accuracy. They are graded for completion. But if you have questions on them, certainly bring those with you. So tomorrow we will do review sheet 5, and then one more additional review day when you return on Tuesday.